Today we're going to be talking about the scientific method. This is something new that I've added to my courses because over the past year or so I've seen a lot of people forget how central the scientific method is to psychology and research. We kind of have lost the idea that the scientific method should be driving everything that we do. And I apologize. Also, I'm getting over a spring summer cold here, so if I sound a little stuffy, it's because of that. So without further ado, let's get into the scientific method. So we're going to talk first briefly about research methodology, and that applies to both experimental and non-experimental methods. But this course, which is experimental, is also going to be based on the scientific method, because as I said earlier, we've kind of lost this focus that the scientific method should be what's driving us in our conceptualization of research. So everything in this course is going to be based off the scientific method. And you should be familiar with most of the components of the scientific method, but researchers and other professionals out there, people in industry, for example, are going to rely on research in order to study human behavior. And we do that because behavior is something that doesn't naturally occur in a scientific format. We have to take science and we have to apply science to human behavior in order to fully be able to study it. We have to conceptualize and we have to define behavior in and of itself before we can go out there and start studying it. So by taking a research methods course, whether it be experimental or not, you're learning a fundamental way of thinking that'll help you be ready to enter the workforce or ready to enter graduate school with a bunch of competencies that are going to make you a valuable commodity. So how do we go about getting knowledge and acquiring information? Let's talk about several different methods that exist out there when it comes to gathering knowledge. The first one we're going to talk about is tenacity. And in tenacity, we're going to have information that we process and we're going to accept it as being accurate simply based on a long-term belief or a superstition. So think about McDonald's with its slogan, "I'm loving it." Do we know that people actually love McDonald's? I don't know. But if you put that forward there, "I'm loving it," over and over and over again, if you were an alien visiting Earth for the first time and you saw that, you might come away from those commercials with an understanding that McDonald's is like the bomb. It's the thing everybody wants, simply because it has been put out there over and over and over again with a slogan like, "I'm loving it," and so everyone tends to believe it. Now, tenacity, you could also think about things like superstitions. Like, for example, when my son was a baby and he started teething, my mother-in-law, may she rest in peace, would often tell me I needed to rub tequila on his gums to soothe his teething pains. Now, that's not something science would recommend, but based on superstition and tenacity, that was a long-term belief that in my mother-in-law's community was accepted as accurate. Obviously, you can see the limitations behind that. There is a huge potential for just inaccurate information to go around. And once that inaccurate information is out there, there is not a reliable method for correcting those erroneous ideas. They are embedded in the population, and that's it. So tenacity, when you describe a person as being tenacious, they don't give up on something. So an idea that is gathered through the method of tenacity is a long-held belief. Whether or not we have proof out there to say that it is not true is a different story. The next one we're going to talk about is intuition. And if you read the first chapter of Morling's book, she focuses a lot on intuition, because intuition is something that we as human beings tend to rely on a lot. So intuition is your hunch or your gut feeling. So this PowerPoint slide here says provides answers to personal choices like what should I have for dinner. Obviously, you're going to go with what your hunch or your gut feeling feels, right? But there's no scientific proof or evidence or anything that's backing up intuition. It's a feeling. So the limitation, obviously, with intuition is that we have no method for separating knowledge that is accurate versus inaccurate knowledge, because we're simply relying on our intuition. Authority is getting a little bit closer to what we want to have in our scientific research conversations. Authority is when we rely on information or answers that come from an expert in a field. This is often the quickest and easiest way to get an answer. So if you think about whenever there is a newsworthy event out there that is scientific in nature, a lot of our news sources will have an authority figure come on and they will ask them questions about what's going on. So, for example, the hantavirus stuff that was going on a couple of weeks ago, they had on one of the news broadcasts that I looked at, they had a virologist, a physician who studies viruses, because the hantavirus is a virus that is, circulating, unfortunately, at the moment. So there are limitations when we use an authority figure. Your authority figure is only able to provide accurate information in their field of study, and even then, their statements that they're providing to you may be subjective in nature. And subjectivity in science is something that we don't want. We want to be objective. The second thing that I want you to remember is that just because someone is an expert, it doesn't mean they're qualified to speak on a certain situation. So I'm a parent, right? And I could be seen as authority as a parent. But what I speak about as a parent authority and what my mom would speak about as a parent authority are different things. So you have to be careful. You have to be able to separate true information that's coming from an authority figure and separate it out and be able to judge it based on a separate set of qualities that you have as a good consumer of scientific information. Now, another method of obtaining information is the rational method. And there's an example in your notes here. It says all 3-year-old children are afraid of the dark. Child A is a 3-year-old. Therefore, child A is afraid of the dark. So this is using a logical set of statements to apply a premise outside of a singular situation. So the first two statements, all 3-year-old children are afraid of the dark and child A is a 3-year-old, those are premise statements. And the third is a logical conclusion. So in that example, we're making a conclusion that a child is afraid of the dark simply because someone said all 3-year-old children are afraid of the dark. So what you've got here is an argument, and an argument is a set of premise statements that are logically built and combined to yield a conclusion. Now, the rational method seems better than intuition or tenacity, right? However, you still have to remember that there are limitations to that rational method. Those logical conclusions are only going to be valid if your premise statement is true. So, if you think back to the example, not all 3-year-olds are afraid of the dark. I know some 3-year-olds who would probably be happy in the dark. So that blows our whole premise logic statement from the previous slide out the window. The problem with this too is that rational methods assume that your premise statements are true. The second thing is that people are not always the most logical when it comes to their reasoning. So even if your argument does not have support for it, it's you're going to have people that believe it, even if they're not able to logically reason through the situation. Now, Morling's book focuses on the empirical method, and the empirical method is getting to things that are closer to where we want to be in research methodology. So empiricism is when we answer questions using observations or personal experience. And Morling goes deep into personal experience as being something we don't want to use in science. And that's correct. We do not want our personal experience to be used. So empiricism needs to be redefined in the context of this slide by going off of direct observations only. Now, empirical method is wonderful when it comes to non-experimental research, okay? Because it's relying on observations, and that's collecting data. And that's great. That's where we want to be. But you have to remember that observations are not always perfect. We have two observers that can observe the same event, and they can interpret that event in different ways. So you always have that possibility of misinterpretation. Beliefs can also get involved with your sensory experience of an observation, and it can cause problems. It takes a long time to observe human behavior, and sometimes there are certain things that would expose the investigator and or the participant to danger. So empirically looking at things is not always the best answer. So to summarize, we've gone through tenacity, intuition, authority, rationalism, and empiricism. And you've seen the positives and the negatives of both of these. So where do we stand when it comes to experimental research? We stand on the scientific method. So the scientific method is an approach to acquiring knowledge that is going to involve us formulating questions and then systematically finding answers to those questions. And it combines a lot of different methods. The first step of our scientific method is to observe behavior or other phenomena. And this is where, in this class, where we're focusing on experimental research, we're going to base our experimental research off of non-experimental research. If you recall from that course, we talked specifically about observing behavior and then coming up with correlations. Once we know that two behaviors or two things or two variables are correlated, then we can move forward with that into the realm of experiments. So we need to focus on what an induction is as well. So an induction is a set of specific observations that forms a general statement about those observations. Induction increases our scope. After we have an idea that's correlated, we now want to come up with a tentative answer or explanation, and this is often referred to as our hypothesis. In a hypothesis, we need to know our variables, our characteristics, and our conditions, and we need to know how those are different between different individuals or groups. Your hypothesis is a statement that explains a relationship between those variables, but it's not a final answer. And be careful, because we're talking about hypothesis within the context of a scientific method here, not within the context of hypothesis testing. And that'll become clear later in the course. Next, once you have your hypothesis, we're going to come up with a testable prediction. And this is where we bring in deductions. So a deduction is going to be a general statement that we use to reach a conclusion about specific examples, and it's going to decrease your scope. It's going to narrow or focus it. So here's an example. It says two testable predictions derived from a general hypothesis. The original hypothesis here is that swearing, the use of curse words, reduces the experience of pain. So prediction 1 says participants should be less responsive to pain when swearing than when not swearing. And then prediction 2 says participants should have an increased tolerance for pain when swearing than when not swearing. Both of those are based off of our original hypothesis. They just set up this research question in two different ways that we can now go on to test. Both of those hypotheses are testable, and that is an important concept as well. Your hypothesis has to be able to be tested. Without a testable hypothesis, we're operating in the realms of the what ifs and the could it be's. Here is an example of how induction and deduction work, from going from a set of all possible cases to a few specific cases. So if you start over here from an induction point of view, you're taking a small set of examples and you're going to, through induction, come up with a situation that you can apply to everything else. So the example given here are, I ate 3 green apples and all were sour, therefore all green apples are sour. And hopefully that'll look familiar to you when you go back to what we talked about earlier with the 3-year-olds in the dark, right? A deduction predicts a small set of specific examples from a general statement about all of the possibilities. So this says all green apples are sour, therefore if I eat a green apple, it's going to have to be sour. So you can see these two things kind of work together with each other. Our next step in the scientific method, step 4, is going to be to evaluate the prediction by making systematic, planned observations. So this is where we have a fair and unbiased test of our research hypothesis. This is the experiment portion, right? You're going to conduct an experiment. And in step 5, you use the data to support, refute, or refine your original hypothesis. So this is after you've analyzed the data and you've crunched your numbers and you've come up with a decision about what you're going to do. Now, hopefully, you'll begin to see here that the scientific method is not a line. It's not a linear process. It's circular, or it goes back and asks you to refine and repeat, refine and repeat. So here's an example of that put into an image. So you start with an observation, you make a hypothesis, you make a prediction, you do your experiment, you've got your data collection, and what does that generate? A new hypothesis. Maybe another researcher comes along and sees your research. They come up with a new hypothesis. They go through the same series of predictions, planned observations through an experiment, and then they come up with a new hypothesis. So the scientific method is circular, and it asks you to go back, and it's iterative, okay, to use a word from the last course that I taught. Other things you need to remember about the scientific method: it's got to be empirical, and empirical is something that we built on from those earlier talks about how to get information, right? Empirical means that science is going to have structured and systematic observations. Those phenomena that we're observing are going to be natural, they're accessible to the senses, and it's measurable. Public means that we share our observations and our findings. We do that through presentations, through publishing our research, to getting your doctorate degree and defending your dissertation. We share that information. We don't sit on it and hide it. And then science has to be objective. Observations and studies have to be structured. They have to be controlled. You have to control your own bias, your own beliefs, and you want to, at all costs, avoid inaccurate conclusions. Now, Morling in her book spends a lot of time talking about pseudoscience. Please be careful, because pseudoscience is something that is out there and it rears its ugly head all of the time. Pseudoscience is a situation where information is presented as actual science, but it's really not, because it lacks something. It lacks some of the key components, one or all. Pseudoscience is not falsifiable, it's not objective, and it's biased, right? It does not invite people to come in and test or challenge through experimentation. And pseudoscience it's based on garbage, really. So a couple of examples are aromatherapy, astrology, etc. So let's talk about the research process for a moment. We have quantitative and qualitative research. Quantitative is going to produce data that is numerical, using variables that can be collected on a numerical stance. All right, we can use statistics to analyze, summarize, and then interpret those statistics. Qualitative research is based on observations, they're summarized, and they're interpreted in a narrative report. And there's a big distinction between the two of those. In this class, when it comes to your research proposal that you're going to write, we are going to focus on quantitative research. Qualitative research has its place, but in this class, that's not what we are focusing on. So to summarize the steps of our research process, we're going to find a research idea, okay? We're going to select a topic, and we're going to do a literature review, and that's one of the things that you're going to do this week in your assignment. The second step is that we're going to form a hypothesis. In the third step, we're going to define our variables, how we're going to measure our data. In the fourth step, we're going to identify our participants or our subjects, and we're going to decide how we select them. And then we're going to also plan so that they're treated ethically. We're going to also, in step 5, come up with a research strategy. In 6, we come up with a research design. 7, we do our study, collecting data as we go. Step 8, we evaluate the data and the statistics associated with it. We also report our results, and then we start over again because research is an iterative process. There is a handout in Canvas that I would like you to reference when we're thinking about this. I'm going to escape out of this at the moment and pull this up so we can talk about it. So, if you have that handout close by, you can look at it. But let's start looking at it here. So the first, we're going to find a research idea, select a topic, and search the literature to find an unanswered question. That's what we're going to be focusing on this week in your paper writing experience, right? We're going to find a topic that you want to do an experiment on, and I have a list of particular questions that you can answer in Canvas. You're going to pick one of those, and you're going to go and search the literature and find out what's out there and what's been done. Now, as a researcher, after you've done that literature review, we usually come up with a hypothesis for our own research. You're going to come up with that tentative answer to your research question. Step 3 down here is where we determine how we're going to define and measure our variables. We're going to talk about that next week when we get into operationalizing variables. There's a very huge focus on that. We want to make sure that our way that we're measuring our variables is very well defined, because that helps us and other researchers understand what it is that you're doing. We also have to look at the validity and the reliability of the measurements that we're using. Step 4 was our subjects and participants. We're going to talk about how we would plan for that and their ethical treatment. Number 5 is where we come up with our research strategy. We have to remember to consider things like our internal and external validity. This is where you would decide if it's going to be an experiment or a descriptive or a correlational study. Remember, for this course, it's going to be experimental. And then 6, we do our research design. Now, this is where we would stop for our paper for this class. We're not going to go into the remainder of these things because you're only proposing something. But in the real world, we would go ahead and do our study, collecting our data, analyzing our data, reporting our data, and then repeating this process again as we refine and reformulate our research idea. So I would definitely look at this handout for your test that you're going to take at the midterm. This is something that I would definitely pull questions from. Let's go back to our presentation here. So to summarize this particular video, we talked about the different ways of collecting, of looking at data, authority. We looked at tenacity. And we said those things are great, but we're going to focus in this course on the scientific method, which is empirical, public, and objective. We also looked at the different steps of the scientific method: observing a behavior, coming up with a tentative answer explanation. Those two things are generally done through non-experimental ways, right? It's where we have our correlational studies that are going to generate our research questions in experiments. Then we talked about how we're going to come up with a hypothesis. We're going to evaluate our prediction in a systematic, planned set of observations in an experiment. And then we're going to use what we see as observations, which is another word for data, to support, refute, or refine our original hypothesis. Marie also talked about the difference between qualitative and quantitative, and you can scratch this. I should have taken that off. This was from a previous course where both of these methods were taught at the same time, but we are focusing only on experimental. That is our focus. So this is just one of several videos that you are supposed to watch this week. So if you have any questions, please let me know, and take care.